Most eVTOLs are built for short city hops, but these aircraft are trying to do something harder. Take off like a helicopter, then fly real distance like an airplane. Some use hydrogen fuel cells. Some use hybrid electric generators. Some use turboshaft engines. And some hide lift fans inside the wings. The goal is simple: vertical takeoff, airplane-style cruise, useful range, and real payload. But the challenge is huge: safety, transition, noise, certification, and operating cost. So today we're counting down 10 unique hybrid and alternative energy VTOL aircraft using real specs like range, speed, payload, seating, and powertrain. Let's start with number 10. Number 10. FLYTER. Developer, Scienex. Type: Compact Hydrogen Fuel Cell VTOL. At number 10 is FLYTER from Scienex. This is one of the smallest aircraft in the countdown, and it should not be judged like a normal airplane. FLYTER is not trying to replace a regional aircraft. It is closer to a compact urban mobility vehicle that can take off vertically, carry 2 people, and fly short city or suburban routes. The most interesting part is the propulsion concept. Scienex describes FLYTER as using an effective hydrogen fuel cell propulsion system with no carbon dioxide emissions at the aircraft. It also emphasizes a compact layout with no open propellers, which is important for any aircraft that might operate close to people, buildings, or urban infrastructure. Scienex lists FLYTER with a maximum flight range of 150 kilometers, top speed of 120 kilometers per hour, maximum flight time of 1 hour, maximum flight height of 1,500 meters, carrying capacity of 250 kilograms, fully loaded weight of 850 kilograms, and unladen mass of 600 kilograms. From a pure aviation performance standpoint, those numbers are modest. A top speed of 120 kilometers per hour, or about 75 miles per hour, is not fast for an aircraft. Even a basic light airplane can cruise much faster. But FLYTER is not playing that game. It is designed around short trips where the main advantage is not speed in open air, but avoiding roads, traffic, and runway infrastructure. The 250-kilogram payload is enough for 2 people plus light baggage. That makes it more useful than a single-seat personal aircraft, but still clearly limited. This is not a family vehicle, not an air taxi for 4 passengers, and not a cargo machine. The hydrogen fuel cell idea is what makes it stand out. Battery-only VTOL aircraft have a major energy density problem. Hydrogen offers better energy per kilogram than batteries, but it adds complexity: tanks, safety systems, refueling infrastructure, and certification challenges. The protected propulsion layout is also important. Many eVTOL aircraft use exposed rotors. That creates obvious safety and noise concerns near people. FLYTER's design tries to solve part of that problem by hiding or protecting the propulsion system. Practical verdict: FLYTER is best understood as a compact hydrogen urban VTOL concept. It does not win on speed. It does not win on range. It does not have the payload of a serious air taxi. But it has a simple mission: short-range vertical mobility with a small footprint and protected propulsion. If urban VTOL vehicles ever operate close to people, designs like this may be more realistic than large open rotor machines. Number 9. SKAI. Developer, Alaka'i Technologies. Type: Hydrogen Fuel Cell eVTOL. At number 9 is SKAI from Alaka'i Technologies. SKAI is important because it takes a different approach from most battery-electric eVTOL aircraft. Instead of depending only on batteries, it is built around a hydrogen fuel cell electric powertrain. Alaka'i describes itself as developing hydrogen-powered eVTOL aircraft and says its systems are designed to be simple, safe, and clean. The aircraft uses a wingless, multicopter-style layout with 6 rotors. That means it is mechanically simpler than a tilt-wing or tilt-rotor aircraft. There are no large wings for efficient cruise, no rotating wing sections, and no complex transition from helicopter mode to airplane mode. It rises vertically and flies using distributed electric propulsion. Public eVTOL database specifications list SKAI as a hydrogen hybrid electric passenger VTOL multicopter concept with 1 pilot, 4 passengers, or 5 passengers in autonomous mode. The listed cruise speed is 115 miles per hour, or 185 kilometers per hour. Range is listed at 150 miles, or 241 kilometers, with a maximum flight time of 4 hours, altitude below 10,000 feet, and 6 propellers driven by 6 electric motors. The biggest strength here is endurance. A 4-hour maximum flight time is very different from many battery-only eVTOLs, which often talk about short city routes and limited reserves. Hydrogen fuel cells can provide much better energy density than batteries, and refueling can be faster than charging large battery packs. But SKAI also has a clear weakness. It has no wing. In forward flight, wings are free efficiency. They carry the weight without constantly pushing air downward. A wingless multicopter must keep using rotor thrust to support the aircraft. That is less efficient than a winged VTOL once the aircraft is in cruise. So SKAI's concept depends heavily on hydrogen making up for that aerodynamic disadvantage. The other challenge is infrastructure. Hydrogen sounds great on paper, but aircraft need refueling networks, storage procedures, high-pressure tanks or liquid hydrogen systems, safety protocols, maintenance training, and airport or vertiport support. Practical verdict. SKAI is not the fastest or most aerodynamic VTOL in this video, but it is one of the clearest examples of a hydrogen fuel cell air taxi concept. The simple 6-rotor layout could help reliability. The hydrogen system could help endurance. But the future of SKAI depends on whether hydrogen aviation infrastructure can mature fast enough to support real daily operations. Number 8, ZURI. Developer, ZURI. Type, 5-seat hybrid VTOL regional aircraft. At number 8 is ZURI, and this one is more serious from a regional mobility standpoint. Many eVTOL concepts are built around short city flights. ZURI is different. The goal is not just to fly across a downtown area. The goal is to connect regions, cities, remote communities, business sites, resorts, and locations where a runway may not be available. The current program centers on the ZURI TD2 technology demonstrator, while the future certified aircraft is planned as a 5-seat hybrid VTOL. ZURI's official technology page lists the TD2 demonstrator at 690 kilograms maximum takeoff weight, 200 kilometers per hour cruise speed, and 200 to 250 kilometers of range. The future 5-seat hybrid VTOL is listed at 2,800 kilograms maximum takeoff weight, 350 kilometers per hour cruise speed, and 700 kilometers of range. Those numbers are important. A 700-kilometer aircraft, or about 435 miles, is not a toy. If achieved with useful reserves and payload, that puts ZURI into a very different category from short-hop urban air taxis. It could fly city pair routes that are too short for airlines but too long or too inconvenient by road. ZURI also lists its regional mobility concept with 700 plus kilometers of range, 300 to 350 kilometers per hour cruise speed, and a 26 by 26 meter landing area. That landing footprint is much larger than a car parking space, but far smaller than a runway. The hybrid powertrain is the key. Pure batteries would struggle with a 700-kilometer range target, especially with vertical takeoff and 5 seats. A hybrid system gives the aircraft more onboard energy while still using electric propulsion benefits during vertical lift and transition. From a practical standpoint, ZURI's strongest argument is mission fit. A 350 per hour cruise speed is fast enough to beat road travel by a huge margin. A 700-kilometer range gives it real regional usefulness. And vertical landing means it does not need both endpoints to have runways. The challenge is certification and transition flight. A hybrid VTOL with tilting or distributed propulsion must prove safe vertical lift, safe transition, battery and fuel system safety, and failure handling. Practical verdict. ZURI is one of the more realistic regional VTOL concepts on this list. It is not just a city air taxi. It has the range and speed targets to replace real travel segments. If the TD2 program leads to a certified 5-seat aircraft, ZURI could be useful for regional business travel, remote access, island routes, and premium point-to-point mobility. Number 7, SOAR. Developer, Paragon VTOL Aerospace. Type, hybrid electric ducted fan VTOL concept. At number 7 is SOAR from Paragon VTOL Aerospace. SOAR is one of the most ambitious aircraft in this lineup, but it also needs the most caution. This is not a certified production aircraft. It is a development concept with aggressive performance claims. Paragon lists SOAR with hybrid electric propulsion, proprietary carbon fiber construction, a frost-resistant airframe, 5.5 decibel audio performance, 1,000 horsepower electric motor per ducted unit, 8 passengers plus pilot, and 500 plus miles of range. The company also notes that the image is a rendering and estimated delivery depends on FAA, EASA, and ICAO approval. Those numbers sound impressive. An 8-passenger VTOL aircraft with more than 500 miles of range would be extremely useful. That is not just an air taxi. That could serve regional executive travel, airport bypass missions, emergency medical transport, VIP mobility, and short-haul routes where helicopters are currently expensive and inefficient. The use of ducted units is also interesting. Ducted fans can improve safety around people because the blades are enclosed. They can also help with thrust control and packaging, but they are not automatically quiet or efficient. Noise depends on fan diameter, blade loading, rotational speed, duct geometry, and how the aircraft handles takeoff and landing. The 1,000 horsepower per ducted unit claim is the kind of number that makes engineers pay attention. Vertical takeoff requires massive power, especially for larger passenger aircraft. But power alone is not enough. The aircraft must manage heat, battery discharge, generator output, redundancy, and emergency operation after failures. The strongest part of SOAR is the mission promise. A larger cabin and 500-mile range would make it more useful than many smaller air taxi concepts. The weakest part is maturity. Until there is a prototype, flight test data, certification plan, and verified performance, SOAR should be treated as a high-potential concept, not a near-market aircraft. Practical verdict. SOAR is bold. If the final aircraft can carry 8 passengers plus a pilot and fly more than 500 miles, it would be one of the most capable hybrid VTOLs in its class. But the script should be honest. The specs are company targets, and the aircraft still faces major engineering and certification hurdles. High upside, high risk. Number 6, CityHawk. Developer, Urban Aeronautics. Type, wingless hydrogen electric ducted fan VTOL. At number 6 is CityHawk, one of the strangest looking aircraft in the countdown. CityHawk does not look like a normal airplane. It does not have exposed helicopter rotors. It does not rely on large wings. Instead, it uses a compact body with enclosed ducted rotors, designed for operation in tight urban environments. The aircraft's goal is very specific: vertical access in places where helicopters are difficult, noisy, or unsafe to operate. Forecast International reported that Urban Aeronautics CityHawk uses a hydrogen fuel cell electric propulsion system with fly-by-wire control envisioned. It also cites technical specifications, including 234 km per hour maximum cruising speed and 4,250 pounds maximum takeoff weight. Other reporting on the redesigned hydrogen-powered CityHawk described the latest evolution as seating 4 passengers plus a pilot with a target range of 93 miles or 150 kilometers, a cruise speed around 130 knots or 240 kilometers per hour, and a compact footprint of about 2.5 by 7.7 meters. Noise was projected around 70 dBA at 700 feet. This aircraft is not trying to beat a fixed-wing airplane on efficiency. It has no wing, so it will not be as efficient in cruise as winged VTOL designs like ZURI or Cavorite X7. But that is not the mission. CityHawk is about access. A helicopter needs a large rotor disc and clear space. CityHawk's ducted fan layout is meant to reduce the exposed rotor hazard and allow operations in tighter areas. That could matter for emergency medical services, rescue, police, urban transport, and disaster response. For EMS, this is especially interesting. A medical VTOL aircraft does not always need to fly 500 miles. It needs to land close to the patient, hospital, or accident scene. A compact footprint can be more valuable than top speed. The weakness is energy efficiency. Wingless VTOL aircraft are power-hungry. Hydrogen helps, but the aircraft still needs to prove real range, reserve margin, safety, cooling, and maintenance cost. Practical verdict. CityHawk is not the fastest or longest-range aircraft here. Its value is urban access. If the hydrogen-electric ducted fan system works, CityHawk could be useful for dense city medical response and rescue missions where a conventional helicopter is too large or too exposed. Number 5. ATEA. Developer, Ascendance Flight Technologies. Type, Hybrid Electric VTOL. At number 5 is ATEA from Ascendance Flight Technologies. ATEI is one of the strongest aircraft in the countdown because it is not built around a fantasy use case. It is designed for real missions, passenger transport, medical flights, cargo, surveillance, defense, and regional mobility. Ascendance describes ATEA as the first aircraft powered by its Sterna hybrid pack, developed for passenger transport, medical, cargo, and surveillance missions. Public technical summaries list ATEA as a hybrid electric VTOL with 1 pilot, 4 passengers, 200 km per hour cruise speed, 400 km of range, 2 hours maximum flight time, 10-minute ground turnaround time, and 2,000 kilograms maximum takeoff weight. Other aircraft project descriptions list a Sterna hybrid electric powertrain, combining a turbo generator and batteries, with 400 kilograms payload, 400 kilometers range, 200 kilometers per hour cruise speed, and VTOL operation through a lift plus cruise configuration. The architecture is practical. ATEI uses vertical lift for takeoff and landing, then transitions into forward flight with wings and cruise propellers. This is exactly where hybrid VTOL makes sense. Hover is power-hungry, but cruise is where wings provide efficiency. The 400-kilometer range is enough for real regional missions. That could connect airports to city centers, hospitals to regional trauma centers, offshore sites to logistics bases, or remote communities to larger hubs. ATE also focuses on operating cost and emissions. The company has claimed lower fuel burn and lower direct operating costs compared with helicopters. That matters because replacing helicopters is probably one of the most realistic early markets for hybrid VTOL. Helicopters are flexible, but they are expensive, loud, and maintenance-heavy. If ATEA can provide vertical access with lower noise, lower fuel burn, and lower cost, it has a real business case. The key challenge is certification and reliability. Operators will not switch from helicopters just because a VTOL looks cleaner. They need dispatch reliability, known maintenance cost, safe failure modes, weather capability, and a support network. Practical verdict. ATEA is one of the most realistic hybrid VTOL concepts in this video. It has useful range, a clear cabin size, a practical hybrid powertrain, and missions that make sense. It is not the fastest or most dramatic aircraft here, but it may be one of the most commercially sensible. Number 4. Cavorite X7. Developer, Horizon Aircraft. Former concept, Cavorite X5. Type, Hybrid Electric Fan and Wing VTOL. At number 4 is the Cavorite X7 from Horizon Aircraft. This is an important update. Older videos and articles often mention the Cavorite X5, but Horizon's current aircraft is the Cavorite X7. The design has grown into a 7-seat hybrid VTOL with more useful performance targets. Horizon's official aircraft page lists the Cavorite X7 as a fan and wing aircraft that can take off vertically, then fly like a conventional airplane once in forward flight. The aircraft uses 14 lift fans hidden inside the wings. During cruise, sliding panels cover the fans, reducing drag and making the aircraft more airplane-like. The official specs are strong: 7 passengers total, meaning 6 passengers plus 1 pilot, 1.5-meter wingspan, 11.6-meter length, 2.8-meter height, 2,500 kilogram maximum gross weight, 680 kilogram useful load in vertical takeoff, 815 kilogram useful load in conventional takeoff, gas plus electric energy system, 450 kilometers per hour maximum cruise speed, 800 kilometer maximum range with reserve fuel and mid-load, and 1,450 kilometer maximum ferry range. These numbers make the X7 one of the most compelling aircraft in this list. The fan and wing design solves a real eVTOL problem. Many VTOL aircraft carry exposed rotors or lift systems through the whole flight. That creates drag in cruise. Horizon's approach hides the lift fans after transition, allowing the aircraft to behave more like a fixed-wing airplane. That is important because range and speed come from efficient cruise, not just vertical takeoff. The aircraft also has multiple operating modes. It can land vertically, use a normal runway, or land in an area roughly the size of a tennis court. That gives operators flexibility. If the payload is heavier or conditions are demanding, conventional takeoff may increase performance. If no runway exists, VTOL mode gives access. Horizon also claims the Cavorite X7 could operate with up to 30% lower hydrocarbon emissions than conventional aircraft on similar missions, and as much as 30% lower direct operating costs than a helicopter, conducting a similar regional mission. Practical verdict. Cavorite X7 is one of the most aircraft-like VTOL concepts here. It has useful speed, useful range, 7-seat capacity, and a design that prioritizes clean cruise flight. The big test is certification, transition reliability, and whether the fan and wing system can deliver the promised performance in real operations. Number 3, CycloTech CruiseUp. Former label, Cyclocar. Type, electric VTOL air car with cyclorotor propulsion. At number 3 is CycloTech CruiseUp. This is the aircraft you should use instead of the generic name Cyclocar. The correct current name is CruiseUp, developed by CycloTech, and it is one of the most unusual VTOL concepts in aviation. CruiseUp does not use normal propellers. It uses cyclorotors rotating cylindrical propulsion units that can vector thrust in almost any direction. That means the aircraft can move forward, backward, sideways, brake in mid-air, and transition without tilting the entire cabin. CycloTech's CruiseUp fact sheet lists a 100 kilometer range, 150 kilometer per hour, speed, 42 minute flight time, and dimensions of 6.67 meters long, 3.3 meters wide, and 2.76 meters high. CycloTech also says CruiseUp offers a top speed of 150 kilometers per hour and 100 kilometers of range, aimed at megacity and suburban mobility. From a pure transportation perspective, those numbers are not impressive compared with regional VTOL aircraft. 100 kilometers of range is only about 62 miles. A 150 kilometer per hour top speed is good for urban mobility, but not enough for regional aviation. But CruiseUp is not about long range. It is about control. Cyclorotor propulsion could provide extremely precise maneuverability. In tight urban airspace, that matters. Being able to move sideways or hold position without pitching the cabin could improve passenger comfort and landing precision. That is a different approach from normal multicopters. A typical drone-style aircraft moves by tilting its body. If it wants to fly forward, it pitches forward. If it wants to move sideways, it tilts sideways. CruiseUp cyclorotors can vector thrust directly, which may allow smoother control. The weakness is maturity. Cyclorotor aircraft are less proven at commercial scale than conventional propellers or ducted fans. The system has moving blades, rotating drums, control mechanisms, and a new aerodynamic profile that must prove durability, efficiency, noise, and safety. Practical verdict. CruiseUp does not win on range, payload, or speed. It wins on originality. If personal air vehicles ever become practical, precise control in tight landing zones may matter more than raw cruise speed. CycloTech CruiseUp is one of the clearest examples of how future VTOLs may look very different from helicopters, airplanes, or drones. Number 2, XTI Aerospace TriFan 600. Type, VTOL vertical lift crossover airplane. At number 2 is the XTI Aerospace TriFan 600. This aircraft needs an important update. It should not be described as a pure hybrid electric aircraft in its current form. XTI's newer direction emphasizes 2 turboshaft engines, with the ability to use 100% sustainable aviation fuel, and a future development path toward hybrid electric and electric propulsion as technology matures. XTI Aerospace says the TriFan 600 is planned with more than 950 miles, or 1,500 kilometers, of VTOL range, the ability to carry up to 6 passengers, and point-to-point operations from helipads, parking lots, roads, backyards, or other safe and legal landing areas. The company also says the aircraft can operate at 25,000 feet and at more than twice the speed and range of competing helicopters in air medical missions. The eVTOL News aircraft profile lists the TriFan 600 as a twin-turboshaft passenger VTOL airplane with plans to move toward hybrid electric and eventually all-electric propulsion. It lists seating for 6 or 7 people, including pilot, maximum cruise speed of 345 miles per hour or 555 kilometers per hour, maximum cruise altitude of 25,000 feet, and VTOL range of 700 miles or 1,126 kilometers. The concept uses 3 ducted fans. 2 forward fans pivot for vertical lift and forward thrust, while a rear fan supports vertical lift. This allows the aircraft to take off vertically, operate from a short runway, or use a conventional runway to improve payload and range. That flexibility is the main value. Most eVTOLs are trying to replace a car ride or short helicopter hop. The TriFan 600 is trying to replace both a helicopter and a business aircraft. That is a much bigger mission. If it can take off vertically, cruise at more than 300 miles per hour, climb to 25,000 feet, and fly hundreds of miles, it becomes useful for executives, medical transport, military missions, remote access, and premium regional travel. The cabin is also important. This is not a 2-seat air car. It is a real passenger aircraft concept with space closer to business aviation than urban drone mobility. The challenge is complexity. Turboshaft engines, ducted fans, transition flight, pressurization, high-speed cruise, VTOL performance, and certification all make this a difficult aircraft to bring to market. Practical verdict. TriFan 600 is not just an air taxi. It is a proposed new category, a vertical lift business aircraft. If certified and produced, it could be one of the most useful aircraft here because it targets long-range travel, not just short urban routes.
Number 1. ODYS Aviation Alta. Type, long-range hybrid electric VTOL cargo aircraft. And number 1 is ODYS Aviation Alta. For this updated script, Alta is the right choice over Starling and the better main pick over Layla. Starling is more of a legacy concept today, and Layla is the smaller proving platform. Alta is the big mission aircraft. ODYS Aviation says Alta is designed for regional VTOL cargo aviation, combining a 1,200-mile range, 3,500-pound capacity, and flexible cargo capability. On the official Alta page, ODYS states that in cargo configuration, Alta can carry up to 3,500 pounds of payload in transport cargo up to 1,200 miles. The company positions it for day or night operations, adverse weather, remote destinations, and regional logistics. This is why Alta earns the top spot. It is not trying to be a flying car. It is not just another luxury air taxi. It is aimed at a problem aviation actually has: moving useful payload over long distances without depending on runways. A 3,500-pound payload is serious. That can mean medical supplies, emergency equipment, defense cargo, communications gear, batteries, food, water, tools, industrial parts, or humanitarian relief. This is far beyond the tiny package drone category. A 1,200-mile range is also a major number. If achieved with useful payload and reserves, Alta would not be limited to city hops. It could support island logistics, remote communities, disaster zones, offshore operations, military resupply, and regional cargo routes where roads or runways are not available. ODYS also uses Layla as the smaller platform leading toward Alta. Layla is described by ODYS as runway independent, designed for JARUS SORA compliance, with 450-mile range and 8-hour endurance. That matters because large aircraft programs need stepping stones. A smaller uncrewed VTOL can prove flight control software, hybrid propulsion, autonomy, mission planning, logistics workflows, and maintenance assumptions before the company scales to a larger Alta-class aircraft. The hybrid electric architecture is also practical for this mission. Pure battery aircraft struggle when you combine vertical lift, long range, and heavy payload. Hybrid systems can use electric propulsion for control and VTOL flexibility while carrying more onboard energy for cruise. Cargo may also be a more realistic early market than passenger air taxis. Cargo does not need luxury seats. It does not care about window views. It cares about payload, range, reliability, and delivery speed. Practical verdict. Alta earns #1 because it targets one of the strongest real-world use cases for hybrid VTOL, long-range cargo, and mission support. The challenge is still huge. ODYS must prove payload range performance, transition safety, operating cost, certification, autonomy, and reliability. But the mission is clear. Carry real payload, fly real distance, land where runways do not exist. That is what could make Alta one of the most useful hybrid VTOL aircraft of the future. So that is our updated countdown of the top 10 unique hybrid and alternative energy VTOL aircraft. And the biggest lesson is simple. VTOL alone is not enough. To matter in the real world, these aircraft need range, speed, payload, safety, useful operating cost, and a mission that makes sense. FLYTER focuses on compact hydrogen urban mobility. SKAI uses hydrogen fuel cells to extend eVTOL endurance. ZURI targets regional travel with a 5-seat hybrid aircraft. SOAR pushes for large passenger capacity and long-range ducted-fan VTOL. CityHawk focuses on dense urban access and emergency response. ATEA is built as a lower-cost helicopter alternative. Cavorite X7 uses fan and wing technology to reduce cruise drag. CycloTech CruiseUp introduces one of the strangest propulsion systems in aviation. TriFan 600 aims to become a vertical lift business aircraft, and ODYS Alta targets long-range cargo and mission support without runway dependence. The future of VTOL will not be one aircraft. It will be a mix of short-range urban vehicles, hydrogen eVTOLs, hybrid regional aircraft, cargo drones, rescue platforms, and maybe one day, true vertical lift business aircraft. But only a few will survive the hardest test. Can they fly safely, carry useful payload, get certified, and operate at a cost that customers will actually pay? That is what separates a cool rendering from a real aircraft. Which one do you think has the best chance? The long-range ODYS Alta, the business VTOL TriFan 600, the fan and wing Cavorite X7, or the hydrogen-powered SKAI? Let us know in the comments. And if you enjoy real aircraft specs, future aviation technology, private jets, VTOL aircraft, and practical aviation reviews without the fluff, make sure to like this video, subscribe, and turn on notifications. This is Unbox the World, where we break down the most interesting aircraft, machines, and future travel technology on the planet. Thanks for watching, and we'll see you in the next flight.